Hello everyone. In this video, we are going to talk about cost indifference point. Let us take a simple example. Suppose a firm wants to replace one of its existing machines and two alternative machines are available. Machine A and Machine B. The costs associated with the two machines is as shown in the table. We are required to calculate cost indifference point and we are required to suggest the most economical alternative machine if the expected level of annual production is 5,000 units and if the expected level of annual production is 1,000 units. So taking this simple example, we can understand what is cost indifference point, how we can calculate cost indifference point, and how cost indifference point can be helpful in answering the second part of this question. So what is cost indifference point? Cost indifference point is the point or the level of output where total cost associated with the two machines is same. In order to calculate cost indifference point, we use the formula difference in fixed cost divided by difference in variable cost per unit. So if we use this formula, then cost indifference point can be calculated by selecting the values given to us on this Excel sheet. So we will select total fixed cost of machine B minus total fixed cost of machine A, and then we take difference between variable cost per unit, 50 minus 10. So here cost indifference point is 2500 units. Let me specify that this is cost indifference point in units. So at 2500 units of output, total cost is going to be same for both machine A and machine B. Now let me depict cost indifference point graphically because graphical presentation is very helpful in answering the second point. So in order to present it graphically, I'll take units produced. I'll start with 0 and I will take it till 8,000 units. So suppose I take number of units from 0 to 8,000 units. Now we can easily calculate total variable cost, total fixed cost and total cost for the various units of output. So total variable cost in case of machine A is number of units produced multiplied by variable cost per unit. Now I'm going to fix the cell by adding a dollar sign. So I have total variable cost with me for the various levels of output. Now what is total fixed cost of machine A? Total fixed cost of machine A is rupees 50,000. Now total fixed cost remains fixed. So I'm going to fix the cell. So total fixed cost is rupees 50,000 for the different levels of output. Now total cost of machine A is total variable cost plus total fixed cost. Now again if I drag this, I get total cost for machine A. In the similar manner, I can calculate total variable cost for machine B, which is number of units produced multiplied by variable cost per unit. Number of units produced multiplied by variable cost per unit, and since variable cost per unit remains same, I'm going to fix the cell. Total fixed cost of machine B is 1,50,000. Again I'm going to fix the cell. Total cost of machine B is Total variable cost plus total fixed cost. Now, in this table, I have total cost of machine A as well as total cost of machine B. Now, I am going to prepare a graph that shows what is total cost of machine A at various units of output, and similarly, what is total cost of machine B for the various levels of output. Now, in order to draw this on graph, I am going to select the number of units. I am going to press the control key. Then I will select total cost of machine A and I will select total cost of machine B. Now I will go to insert. Under charts, I am going to select scatter. Scatter with straight lines. Now I press OK. I get this chart. Now see, let me give this chart a title. Machine A versus machine B. Now on x-axis here, let me label the axis as well. Here on x-axis I have units. And on y-axis, I have cost. Now, let us look at the graph. Here, this graph shows, let me increase the size of the graph. Now here, this graph shows blue line, which is total cost of machine A, and an orange colored line which shows total cost of machine B. Now these two lines intersect at this point. This point where the two lines intersect each other is the cost indifference point. So I would like to make this point prominent to clearly show the cost indifference point. Now in order to make it prominent, I right click on this data point. Let me show again. I click on this line and I click again specifically at this point. Now here I right click. I go to format data point. Then I'll go to this option. Here I get an option to mark this point, marker. Here under marker options, some built-in options are available. So I choose to mark my point. I can choose any of these options. So suppose I choose this triangle, small triangle to mark my point. I increase the size to make it more prominent. And I want to choose a different color. So suppose I choose black color to mark this point. I'm choosing black color to mark the point. Now my point is prominent here. So this point, which is indicated by the small triangle, is the cost indifference point. Let me label this point as well. So I again click on this point. I right click and I go to add data label. Now here the data label is clearly visible, but I also want some additional information. This data label shows Y value. In other words, it shows cost, total cost at the cost indifference point. So suppose I also want to know the number of units at the cost indifference point. So what I can do is, I can again click on this point. I right click and I go to format data label. Because I already have the data label, now I get this option to format data label. Now here I have the option to show X value. On X axis we have units. So I choose to see X value. So suppose I don't want to see the Y value. I am mainly interested in showing the X value. that is number of units at cost indifference point. So I select X. Now see. 2500 units. We had calculated 2500 units as the cost indifference point. Now, it is clearly shown here as well. You can see on the table as well that at 2500 units, let me highlight this, for 2500 units, total cost is same for machine A as well as machine B. And this is what we had calculated also. Cost indifference point is 2500 units. And this is clearly shown in the graph as well, that the point of intersection is 2500 units. Now let me label this to make it more clear. So I choose to add a text box here to clearly specify that this is the cost indifference point. Right. So here I have clearly labeled that this point of intersection is the cost indifference point in units. Okay, now let's come to the second part. We have solved the first part, that is we have calculated the cost indifference point using the formula. We can clearly see it in the table as well, and we can clearly see the cost indifference point on the graph as well. Now let us come to the second part of the question. The second part says, suggest the most economical alternative machine to replace the existing one when the expected level of annual production is 5000 units or 1000 units. So let us look at 5000 units first. Now let us look at this graph. This graph can make it really easy for us to answer the second part. Now in this graph, it is quite clear that after reaching cost indifference point, in other words, beyond 2500 units, if we see, blue line lies above the orange line. In other words, after 2500 units of output, total cost of machine A is going to be more than total cost of machine B. So in simple words, if the level of production is expected to be more than 2500 units, then the more economical option is to go for machine B, because with machine B, the total cost is going to be less. So beyond 2500, our clear choice is machine B. So let us see, let us indicate that on the graph as well. We can clearly see that for 5000 units, orange line is below the blue line. In other words, to produce 5000 units, total cost of machine B is less than total cost of machine A. So if I want to clearly mark it on the graph, I can go to insert, I can choose illustrations, and I can choose any shape. So suppose I choose this arrow. I choose this arrow to indicate 5000 units of output, and I mark it with black color. Now for 5000 units of output, total cost of A is more than B, so my clear choice is choose B. In fact, it is better that we insert a text box here and clearly specify that it is the machine B which is the clear choice after cost indifference point. And the second part of the question is, second part here is, B part here is 1000 units. that if the expected level of production is 1000 units, then what is the most economical alternative? Again, let's see. Let's go to insert, illustrations, shapes. I again choose arrow. It is quite clear. I insert an arrow here. I'm inserting an arrow just to make it more clear. I choose black color again. Now again we can clearly see that for 1000 units of output, the orange line lies above the blue line. In other words, if the level of production is expected to be 1000 units, then total cost of machine A is lower. So it is recommended that machine A should be used if level of production is expected to be 1000 units. In fact, for any level of production which is less than cost indifference point, any level of production which is lower than 2500 units, it is better to choose machine A because total cost of machine A is below the total cost of machine B. So here we can again specify by inserting a text box. Choose A. So through this graph, the choice becomes quite easy to understand. At any level of output, we can look at the graph and clearly see which machine is giving lower total cost and we can make a choice. In fact, the general rule is that for output levels above cost indifference point, I am repeating, for output levels above cost indifference point, it is recommended that the machine with higher total fixed cost can be chosen. And for output levels less than cost indifference point, it is recommended that machine with lower total fixed cost is more suitable. But the graph makes it more clear. So in this way, through graphical representation, we can understand the concept of cost indifference point. Thank you.